Ladies and gentlemen, notes 3.6 are on solving quadratic equations. This is the second day of our notes, and we're going to apply our information for solving quadratic equations to word problems. So number 1 says a water balloon is catapulted into the air from the top of a building. The height, h of t in meters, of the balloon after t seconds is h of t is equal to negative 5t squared plus 30t plus 10. So the first thing I want to do is find the domain and range of this function. Well, a couple of things that we need to notice. This 10 right here is our y-intercept. So we know that that's going to be our highest, or our starting point. We also know that since the a value is negative, it's going to open down. Okay, so when I take a look at what I have here, if I were to draw a sketch of my graph, I know that it's going to start at 10, it's going to reach some maximum value, and then it's going to hit the ground. Okay, so I want to know essentially what my domain and my range are going to be based on this graph right here. So if I know that this is the height, and if I know that this is the time right here, then I can figure out, well, the smallest time will be from 0 until this root, and then the smallest height will be from 0, because that's when it hits the ground, to whatever my maximum value here is. Okay, so a couple things I need to do is I need to find roots, and I also need to find the vertex. Okay, so I'm going to find the vertex first. So I'm going to put my equation in vertex form. So looking at this right here, I'm going to factor out a negative 5, and when I do that, I end up getting t squared minus 6t. I'm going to leave some space, and I'm going to write plus 10 on the end. Now, to complete the square, I take this negative 6, divide it by 2, and then I square it. So I end up getting negative 3 squared, which is positive 9. So I'm going to add 9, but to get rid of that plus 9, I need to also subtract 9. So then when I distribute this negative 5 through here, I end up getting h of t is equal to negative 5 times t squared minus 6t plus 9. Okay, negative 5 times negative 9 is positive 45 plus 10. All right, so I end up getting h of t is equal to negative 5 times t minus 3 squared plus 55. So I know that my vertex right here is going to happen at 3, 55. So I know what my maximum height is going to be. Awesome. Now that I've found my vertex, so we can say therefore vertex is going to be 355. Now that I've found my vertex, I'm going to find the roots. So I'm going to use this equation right here to find my roots. So instead of h of t here, I'm going to set it equal to 0. So I get 0 equals negative 5 times t minus 3 squared plus 55. Now, to get rid of this 55 right here, I'm going to subtract it. So I end up getting negative 55 equals negative 5 multiplied by t minus 3 squared. Okay, divide both sides by negative 5, and I get 11 equals t minus 3 quantity squared. Next, I would have to square root both sides. So I get plus or minus square root of 11 equals t minus 3. Okay, so therefore I can say that t is equal to, I would add 3 to both sides, so I would get 3 plus or minus the square root of 11. But these values don't really mean anything to me because I need to know what it is specifically in terms of time, and I'm not going to say that the time occurs at 3 plus the square root of 11. So I need to type that into my calculator. So when I do that, I end up getting here time is equal to 3 plus the square root of 11, and time is equal to 3 minus the square root of 11. So when I do 3 plus the square root of 11 right here, I end up getting 6.317. So we'll say t is approximately equal to 6.317. And then when I do 3 minus the square root of 11, so then when I do 3 minus the square root of 11, I end up getting negative 0.317. So t here ends up being 6.317, and here I end up getting negative 0.317. Well, this time right here is extraneous because it's not possible for me to have negative time, okay? So I don't worry about this. This value right here is where my root over here is going to be, okay? So now, looking at my graph right here, I can see that my domain is going to be from 0 to 6.317, because anything after that will give me a negative height, which isn't going to work for me. So to find the domain, I can see that the smallest time that we have is 0 seconds, because we don't have negative time, and it goes all the way until it hits the floor, and it hits the ground at 6.317 seconds. So my domain is going to be t is an element of the reals such that t is between 0 seconds and 6.317 seconds. Okay, and then for my range right here, I know that it's going to hit the ground, so that's the lowest value it'll hit at. So 0 is the lowest height, but the maximum height is 55. So the range is going to be h of t is an element of the reals such that h of t is between 0 and 55 meters. Okay, so this is the domain and range that we have here. For part B, we're going to talk about that part in class, so you can just leave that part blank. Okay. Number 2, a factory is to be built on a lot that measures 80 meters by 60 meters. A lawn of uniform width equal to the area of the factory must surround it. How wide is the strip of lawn, and what are the dimensions of the factory? Okay, so the first thing I'm going to want to do is draw a picture of my lot, okay? And I know that it measures 80 meters by 60 meters. So now that I know that, I also know that there's going to be a lawn of uniform width equal to the area of the factory that's going to surround it. So that means that my factory is going to go inside my lawn, and I know that this right here has a width of x. So from here to here we have x, and that means right here, so again, this width right here is x, which means that this width right here is also going to be x, okay? So looking at what we have here, we can conclude that since from here to here is a full 80, then this piece right here is going to be 80 minus this x, and this x would be 80 minus 2x. So in my factory right here, the length here is going to be 80 minus 2x. Now the width here is going to end up being 60 minus 2x. Okay, so to find the area of the factory, I'm going to take my length and my width and I'm going to multiply them. So it'd be 80 minus 2x times 60 minus 2x. So that means the area of the factory, again, is going to be equal to 80 times 60 is 4,800, okay? 80 times negative 2x is minus 160x. Negative 2x times 60 is minus 120x. And then negative 2x times negative 2x is positive 4x squared. When I put everything together in descending order, I end up getting 4x squared. These guys right here get put together, I get minus 280x, and then I have a plus 4,800 left over. And that's the area, again, of my factory. Now that I know that, I want to figure out, well, what should the area of my factory be equal to? Well, it says that the lawn of uniform width is equal to the area of, the factory must surround it. So that means that the area of what we have on the outside right here is equal to the area of what we have on the inside right here. So therefore, two of these areas together should equal the area of the full lot. So the area of the full lot is going to be equal to 80 meters by 60 meters. So it's equal to 4,800 meters squared. And if the green area inside of here and the red area are going to be the same, then the area of the factory is going to be half of the area of this lot right here. So it's going to be 1/2 of 4,800, which is 2,400 meters squared. So now I know that this area is going to have to be 2,400 meters squared, or I don't need to put the unit, so I'll just put equals 2,400. So 2,400 equals 4x squared minus 280x plus 4,800. Now, since I have a squared here, I need to get everything on one side. So I'm going to subtract this 2,400 from both sides. and I end up getting 0 equals 4x squared minus 280x plus this ends up being 2400. Okay, so now I'm going to go through and I'm going to factor. The first question I ask myself whenever I factor is there a GCF? And all of these values can be divided by 4. So I'm going to factor out of 4, and I'll have x squared left over. 280 divided by 4 is 70x, and then 2400 divided by 4 is going to give me 600. Okay, so now that I've done that, I'm going to look and see if I can factor what's inside of here. So I get 0 equals 4, and then in my brackets here, I'm going to have an x and an x, and I'm going to look for factors of 600 that could add up to give me negative 70. So I'm going to try 60 and 10, because 60 times 10 is 600. This gives me 60x. This gives me 10x, and when I put them together, if they're both negatives, then I would end up getting negative 70x. So these both have to be negative here. Okay, so then once I've done that, I'm going to set each part equal to 0. So 4 equals 0, but that's not possible, so I'm not even going to worry about that one. I'm going to say x minus 60 equals 0, so therefore x is 60. And here I'm going to say x minus 10 equals 0, so therefore x equals 10. So my two possibilities for x are 60 and 10. But if I go back in here and I plug in 60 into my new dimension here, we know that this is 80 minus 2x, but if x is 60, then it would be 80 minus 2 times 60, which is 80 minus 120, which is negative 40. And negative 40 is not possible for a length or a width. So we're going to say that the 60 right here is inadmissible. It's not possible for x to be equal to 60. All right, so now let's try it again, but instead of with 60, let's try it with this 10. So 80 minus 2 times 10, so it'd get 80 minus 20, which is 60. So that's possible for one length. Let's figure out the other length here. This 60 minus 2x would be 60 minus 2 times 10. So I'd get 60 minus 20, which is 40 meters. And so it's possible to have 60 meters for one and 40 for the other. We can say, therefore, the width of the strip of the lawn is, right here, our answer here, we're looking for x, and we got x is 10 meters. And the dimensions of the factory are 60 meters by 40 meters. Okay? All right, guys, last one. Number 3, find 3 consecutive positive odd integers such that the sum of 3 times the first and the square of the second is 97 less than 7 times the third. First of all, I want you guys to please correct the typo that we have here. This shouldn't say 97 less than, it should say 97 more than, okay? So it's 97 more than 7 times the third. So as soon as I see 3 consecutive positive odd integers, I'm going to go straight to my let statements. So if there are 3 things I don't know, I'm going to write 3 let statements. So we're going to say let first consecutive positive odd integer equal x. Okay, so then we're going to say let the second, and then you don't have to rewrite it over and over and over again if you don't want to. So if you remember, if the first one is x, the next one is 2 more. So for example, the integer 5, the next odd integer after 5 is 7, because you have to add 2 to go from one integer to the next. So it's going to be x plus 2. And then we're going to let the third consecutive positive odd integer be x plus 4. And now we're going to translate everything that it says here. So do you guys see how it says the sum of 3 times the first? So what I'm going to do is I'm going to take the first, which is x right here, and I'm going to do 3 times x. And then it says in the square of the second, so I'm going to take the second one, which is x plus 2, and I'm going to square it, and it says to find the sum of these two, so I'm going to add them together. Then it says is, so this word right here means I'm going to have to write down equals 97 more than 6 times the third. So 7 times the third. So I have to take this 7 times the third first. I'm going to translate that. So I'm going to do 7 times x plus 4, and then I'm going to do 97 more than that. So I'm going to write plus 97. And that's my equation that I'm going to solve. Okay, so I end up getting 3x plus. I need to expand this all out. If you need to do it on the side, please feel free to do that. But at this point in time, if you feel comfortable enough to figure out what the values are, go ahead and just write out what it's going to be. We want to get to a point where you can just do this in your head. So we know this is going to be x squared. We know the b value is going to be double this amount, so I'm going to write plus 4x. And we know the c value is this amount squared, so 2 squared is plus 4. But if you need to pause and actually do the x plus 2 times x plus 2 on the side to see if you get this, please feel free to do that, okay? And then with the 7 on the outside here, I'm going to distribute that through. So I end up getting 7x plus 28, and then it's plus 97. One thing though, please do not tell me that this is x squared plus 4. Okay, so now I'm going to put together all my like terms on the left side. So first I'm going to do x squared, then I've got 3x and 4x, so altogether that's 7x, and then I'm going to write plus 4 equals, on this side I have a 7x, and then I'm going to put together the 28 and the 97, and when I put those guys together I end up getting positive 125. Okay, then because it's squared I'm going to get everything on one side, so I'm going to subtract the 7x, and I'm going to subtract the 125. So these are gone. So I end up getting x squared. These also cancel out. And then 4 minus 125 is minus 121. And don't forget to write equals 0. Well, looking at this right here, there's no GCF, but I can tell it's a difference of perfect squares because it's a binomial, there's subtraction, and they're perfect squares. So when I factor this as a difference of perfect squares, I'm going to have x plus 11 and x minus 11. So therefore, x would equal negative 11 here, right? We would set each part equal to 0, but I'm just skipping that step now because hopefully at this point in time you guys understand that you can just do the opposite side if the leading coefficient here is 1. So x is either negative 11 or positive 11. But because it says that the integers have to be positive, this one right here is inadmissible, or it's extraneous, which means it doesn't work because it's negative and we need our positive integer. So therefore, the 3 integers are, the first one is going to be 11, the next one is 11 plus 2 or 13, and the next one is 11 plus 4, which is 17. So the 3 integers are, 15, excuse me. So the 3 integers are 11, 13, and 15. Okay?